children, how are you? I hope you all are fine and safe. Stay home, stay safe and take prevention for this COVID-19. Okay? What you are doing? I am doing the same thing, staying home and staying safe. Now, today we are going a new chapter. We are just going for a new chapter. That chapter name is called as the lines and angles. It is the lines and the angles. It is a pure geometrical chapter, and today I am going to give you the introduction about the lines and angles. See now, the introduction part. What is the line? See, I wrote here some basic terms in geometry. In geometry, when you are going for geometry, when we learn geometry, these basic terms said to you, and right now I am just reminding you by just telling them what are they. The number one is called as the point. What is a point? In the last video I said you a point has no dimension. A point has no dimension. That means such as no length, no breadth and no height, and just represented by a dot, that is A and B. Understood now? So what is a point? A point which has no dimension. Dimension means no length, no breadth, no height. That means it is just a point and written and can be denoted by, the symbol is the point is point A, point B, we can say like this. Now come to the next, that is called as a line. A line. What is a line? A line is a set of points. Give a line. A set of points. You will take set of points. See now. You will take, I just took 2 points, and on these 2 points there are a lot of points lying. There are a lot of points lying. Okay. So it is a set of lines. It is a set of points. It is giving you a line. So a line is a set of points. And a straight line can be extended in both the directions. See now. This line A, B. Suppose I am writing here A, B. A and B. So this line can be extended in the both directions. So a line, a straight line has no endpoints. A straight line has no endpoints. It can be extended in both the directions. I hope you understood. Next, come to the point, that is line segment. What is a line segment? The line segment, what is this? A path of a line. A path of a line with 2 endpoints. That means a line segment is a part of a line. It is a part, not a path, it is a part. So a part of a line with 2 endpoints. A part of a line. That means a line segment is a part of a line. If it is a line, I will take a part. Look, I took a part. So that is having a fixed measurement. Okay. And the part of a line with 2 endpoints. There will be 2 endpoints for it, and it cannot be extended in the both directions. So a line segment has 2 fixed endpoints. What is to say? Fixed endpoints. But a straight line has no endpoints. That is the difference between a line, straight line and line segment, and can be denoted by C. Though it is closed, the arrows are closed, so it cannot be extended. So now you see, when you are going to give it, we can give this type of, so it is closed. We can say AB line segment. This is AB line segment. This AB is a line segment and denoted by this symbol AB line segment. Understood now? So now go for the 4th point. The 4th point is the ray. Ray, everybody knows in our daily life. So the ray comes from the sun. So its starting point is there, but there will be no end point. So there will be no end point. It can extend in a direction, in one direction only. Okay. So it begins at a point. It begins at a point and goes endlessly in a specified direction. Endlessly in a specified direction. In some direction it will go. Light rays coming from sun. Endlessly it is going in one direction and touching the earth. So it can be denoted by AB. This is the ray. This is the symbol for ray. So these are all the reminding of your previous basic geometry, basic terms in the geometry, and some others are there. I am going to say now. Now come to the next part. The next part is the basic terms in geometry. The 5th one. What is the 5th one? The 5th one is an angle. So what is an angle? Everybody knows what is an angle. Let me explain about it. An angle is formed by rotating a ray from our initial position to a terminal position. So what is saying? An angle is formed. An angle will be formed if you are rotating a ray from an initial position to a terminal position. Look at it. I draw a figure for you for better understanding. See, this is the initial position of your ray. And when this ray is start to turn and this ray is coming here, then a space created between the two rays. That space is called as an angle. This is a angle. Understood now? So what is saying? An angle is formed by rotating a ray from an initial position to a terminal position. That means a ray is there, and when it is just rotating and coming in this direction, and the space created by this rotation is called as your angle. So for angle, what is needed? See now, point is there. That point is always the common point for both the rays. These are two rays, opposite rays. So this is going that side, this is going this side. So now two rays, the common place is where they are meeting is called as a vertex. What is that called? Vertex. And the space inside that one is called as the angle. And these lines, these rays are called as the arms. What is this called as? Arms. Arms, vertex and the angle. I hope you understood this and understood the definition. An angle is formed by rotating a ray from an initial position to a terminal position. From an initial position to a terminal position, when it is rotated, definitely it is creating an angle. Here I am showing you how the initial position is rotated to a complete rotation. See now, that means the ray is here, that is the initial ray. Now it is going to move here, then it is coming to here, then it is coming to here, then here, then here, and here, again coming to initial. So it is going for a complete rotation. Yes or no? So when it is initial position, here again here it is terminal position, terminal position, terminal, 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 and again coming to the initial. That means when it is coming again to the initial, that is just completing one rotation. That completing is one rotation. So here I wrote one complete rotation is called 360 degree. That means the whole total rotation when a ray is starting from its initial position and coming to the final position, that is from where it starts to come to that position, it is taking one complete rotation, and that rotation is called as 360 degree. I hope you understood it. Now I draw some figures for you. See, very interesting figures. Figure 1 is here. I explained the same thing here again. That is this is called as one arm, this is another arm, and this is called as the vertex, and this place inside it is called as the angle. So angle always formed by what? Two arms. That means two rays, which is having a common point of they are meeting at a common point. That is called as the vertex. Now you see some types of angles. I did it here in figure. The angle which is less than 90 degree. The 90 degree will be here like this, but it is less than 90 degree. So angle is less than 90 degree. Called as acute angles. An angle always starting from 0 degree, and when it is less than 90 degree, it is up to 89 degree. It is called as your acute angle. Then angle that is called equal to 90 degree. That means exactly perpendicular equal to 90 degree. This is called right angle. You already know about this thing. These are the remindings of the last classes. Next it is a obtuse angle. Obtuse angle is just, see, the right angle is here, but it is more than right angle. So it is more than 90, greater than 90, and called as an obtuse angle. So next figure it is, look at it, this angle is totally giving a half rotation. It is totally giving a half, which one? This initial, this to this is the initial ray. So this to this, let it be OA, this is 0 degree, this is 180 degree. OA is the initial, OA is the initial. Now it is coming and rotation and coming to this position again here. So now OA became OB. Now it is giving you a complete half rotation. That is, full rotation is 360 degree. The half rotation will be 180 degree and called as straight angle. Then figure number 6 is the angle which is again here it is 180. Now this ray is coming more than 180. It is greater than 180. That is called as a reflex angle. That is called as a reflex angle. which is greater than 180 degree. Now figure number 7 is a complete angle. What is a complete angle? I said you now, I explain you, when a ray is starting from its initial position and again moving and coming to initial position. What it completes? It completes one complete rotation. It completes one complete rotation. What is that? 360 degree. 360 degree, otherwise called as a complete angle. That means here all types of angle definition and other things for the angle is totally, I think you understood it. So what is an angle? An angle which is a place or the space created by two rays have a common vertex. Then that is called as an angle. What is a complete angle? When the ray is moving and coming to initial position again, it is going for a complete rotation and called as a what? Complete angle, giving you a complete angle, or it is 360 degree. Then I explained you about this angle figure and some of the angles. That means less than 90, acute, equal to 90, right? Greater than 90, it is obtuse. And now it is two right angles, that means 180 degree, half rotation, that is straight angle. More than 180, it is called reflex angle, and it is a complete angle. One complete rotation is giving you a complete angle. I hope you understood this part nicely. This is about your basic terms in the geometry. Now we will start the next part. Now come to the next part. What is the next part? The concurrent lines. Concurrent lines. What is the spelling? Concurrent lines. Concurrent lines. So what is that? See the definition of a concurrent lines. When three or more lines meet at a point, three or more lines, one line, that means ray, another, they are coming to meet in one point. Three or more lines, they are coming to meet at one point. Then these rays, OA, OB, OC, you write here rays, three or more rays, you please write here rays. Okay, rays will be most appropriate here. It will be rays. Clear? And it is called the, what is that? When three or more rays meet at a point, they are called concurrent rays. So that means O to A is a ray, O to Z, O to F, O to E, O to D, O to C, O B. They all are the what? Rays. They are coming to meet at one point. But from one point they are going out. Okay. So these rays, OA, OB, OC, OD, OE, OF, OG, all are called as concurrent rays. So sometimes it is called as concurrent lines also. Sometimes it is called as concurrent lines. Here, but what is the meaning? The meaning is that when they are just meeting at a point, who are the rays? They are meeting at a point, one or more, three or more rays. Don't say one or two. Three or more rays, when they are meeting at one point, they are called as the concurrent rays. And this point, what is this point? Where they are all coming to meet. The point is called as the point of concurrence. Point of concurrence. That means when three or more rays meet at a point, they are called concurrent rays. And the point at which they meet is called as the point of concurrence. This is called as the point of concurrence. Clear? So they are meeting at one point. Definitely they are the rays. That means they are meeting at one point. So the point, their meeting point is only one. That is O. O is called as the point of concurrence. I hope you understood it. Now come to the point. This is the important part. Pair of angles. Pairs of angles. So now I did three figures for you. See, two figures for you. In one figure, this is 90 degree. I divided 90 degree to 60 and 30. In second figure, I draw two separate figures, 40 and 50. Which, if you add them, you are going to get a figure of a 90 degree. Okay. So this is the motto to explain today. Now you see, what is this? Some questions are related with it. What is the sum of the two angles? In the first figure, it is 60 plus 30, how much? 90. Then what is the sum of the angles in the second figure? Is it 90? 40 plus 50, yes, it is 90. So now it is called as 90 degree. The sum is 40 plus 50, it is giving you 90 degree. Then, is it 90? If yes, if it is yes, it is giving you 90 degree, then they are called as the complementary angle. That means these two pairs, these two angles, that means one pair. These two angles, that means one pair. This pair is called as complementary to both. That means 60 is complementary to 30 and 30 is complementary to 60, because when they are adding, they are giving you 90 degrees. That is, it is if a given angle is x, suppose a given angle is given to you x degree, then what should be the complementary angle of the given angle? That will be 90 minus x, means you have to subtract it, the given angle, from 90 degree to get the other angle. And when you will add them, you will get 90 degrees. So both these pairs are called as, pair of angle is called as complementary angle. Again I am discussing, again I am explaining you with some figures, and try to understand. Now you see the pair of angles I already explained you. Here the figures are given. What I said you, what is the sum of these two angles? It is giving you 90 degree. So if a given angle is x degree, then the complementary of this angle will be 90 minus x. That means the sum of the two angles must be 90 degree, a right angle. Then one angle is called as the complementary of the other. Clear? Now you see, I wrote the definitions here. What are the definitions you see? When the sum of the pair of angle is 90 degree, sum of the pair of angle, this is important, sum of the pair of angle. When the sum of the pair of angle is 90 degree, then one angle is called the complementary of the other. Then here the sum of the pair is 60 plus 30, 90 degree. So 60 complementary is 90 minus 60, that is 30 degree. So 30 complementary is 90 minus 60, that is 90 minus 30, that is 60 degree. So 60 degree complementary angle is 30 degree, 30 degree complementary angle is 60 degree. So here also 40 degree is the complementary angle of 50, 50 degree is the complementary angle of 40 degree. So when the sum of the pairs of the angle is 90 degree, when it is 90 degree, then one angle is called as the complementary of the other. One angle is called as the complementary of the other. Complementary to the other. So pair of angle, one angle will be the complementary of the other if the sum of the pair of the angle is 90 degree. I hope you understood. Now come to the second definition. What is the second definition I said to you? When the sum of the pair of the angle is 180 degree, like you are doing here 60 plus 30, 90 degree and saying complementary. Similarly, when the sum of the pair of the angle is 180 degree, here the figure I draw for you. See now, this is a line and another ray is standing on it, and two angles are 130 and 50. Look this pair, these two pairs are giving you 130 plus 50, that is 180 degree. So that is written here, when the sum of the pair of the angle is 180 degree, then one angle is called as the supplementary to the other. That means 130 supplementary is 180 minus 130, that is 50 degree, and 50 degree supplementary is 180 minus 50 degree, that is 130 degree. Like that we can determine the other angles, other supplementary angles also. Clear? So when the sum of the pair of angle, is 180 degree, then one angle is called as the supplementary of to one another. The figure is given here. Like that you take the angles from your own and try to determine the complementary and supplementary part. Next we are going for the next part. Now come to the next part. The next part of the lines and angles is today. The next part is the axiom on the linear pair of angles. What is that? Axiom. Axiom on linear pair of angles. So what is a linear pair of angles? You have to first understand. So linear pair of angles, the definition is given here. The statement for that is given here. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. Right now you see I am explaining this linear pair. What is linear pair of angles? See now, here it is a line and another ray is standing on this. That one it is saying you a ray stands on a line. That means this is the ray, OC is the ray and AB is the line. AB is the line segment and OC is the ray. And the OC is standing on AB. Then how many angles you are observing now? You are observing two angles. Angle number 1, that is BOC, and angle number 2, that is AOC. So these two pair of angles are called as linear pair of angles. These are called as linear pair of angles. Understood now what is linear pair of angles? Then what is the axiom on that? What is the axiom on that? If a ray stands on a line, this is the line, the ray is standing now on AB, AOC is standing now, then the sum of the two adjacent angles. So these are two adjacent angles now. Angle number 1 and angle number 2 is the adjacent angles. What is saying? So formed is 180 degree. When you will go to add them, you will get 1 plus 2 will give you 180 degree. So this is the axiom on linear pair of angles. I hope you understood the linear pair. Linear pair of angles means on a line, if a ray is standing, then two angles are created, two adjacent angles are there. The two angles are called as the linear pair angles. And when you will add that two angles, it will give you 180 degree. That is the axiom of the linear pair of angles. So if a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree. Now I am going to explain this axiom of linear pair of angles by some activity. See an activity I am doing for you. You also do it in your home. So see the activity. What is the activity? Measure the following angles. I say measure the following angles and complete the table. I gave you a table here and I gave you three figures here. First figure is, see, I took a AB line and OC, a ray standing on the line, and two pairs of angles created. I measured them, and one is coming 30 degree, another is coming 150 degree. So you also measure like that. Another line I took, that is AB, and a ray is standing, that is OC, and when I measured them, I got this is coming 90 and this is coming 90 degree also. So now another line, that is AB, and OC is standing on that. Here I measured the two angles. The first angle came 110 degree and the second angle is coming 70 degree. I measured that. For that reason, what I did, I took three figures. You take three figures, that is bit 1, figure number 1. This is figure number 1. This is your figure number 2. This is your figure number 3. Like that, you take three figures in your note, and by the protractor you start to measure the angles. You know how to measure the angles. The protractor base line, here is the protractor and here is your line. The protractor base line, this is called protractor base line. Protractor base line must match to this line must match to your line, and this point in the protractor there is a point also. This point must match to this point. This line must match to this line. Then required angle, what it is the ray is showing, that angle you have to write it here, and also measure this angle also. Clear? So like that, when you will see, when after the measurement, when you will go for a table, there is a figure number 1, figure number 2 and figure number 3 is there. So in figure number 1, you have to write angle number 1. What is angle number 1? You have to write. What is angle number 2? You have to write. And what is 1 plus 2? You have to write angle 1 plus angle 2. Then your remark must be, is it 180 degree? If it is there, write here 180 degree. Clear? So I am writing now. You see how I am writing. In my figure 1, angle number 1 is 30 degree. I wrote. Angle number 2 is 150 degree. And it is 30 plus 150 degree. Clear? 150 degree. Then it is giving me 180 degree. So that is the axiom saying to us, if a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree. Now you understood how it is coming 180 degree. So these two pair of angles are called as the linear pair of angles. And when you say, when you see this type of angles in geometrical figures, you must say, you must be confirmed that these are two linear pair angles, and they will, when they will add them, it will definitely give you two right angles that is equal to 180 degree. I hope you understood it nicely. And do this activity on the note and draw the table and see of yourself, you see whether it is coming 180 degree two right angles or not. I hope you understood it. Now you come to the next part. What is the next part? The next part is the heading angles in intersecting line. Angles in intersecting line. That means when two lines, here one line is RS, another line is PQ. So PQ line and RS line are intersecting each other at point O. So that is the heading angles in intersecting line. What are the angles? How many angles are going to be created by intersecting of two lines? So my first line is PQ and my second line is RS. So they are intersecting each other at the point O. So now they have created angle 1, angle 2, angle 3, this is 2, angle 2, this is angle 2. So angle 1, angle 2, angle 3 and angle 4. So there, how many angles they created? They created 4 angles. After intersection, they created 4 angles. So how many number of angles? 4 angles are there. That is, I wrote here, when two lines intersect each other at a point, when two lines intersect each other at a point, then the number of angles are 4. 4 angles are going to be created. 1, 2, 3, 4. I showed 1 and 3 as a cross and 2 and 4 as dotted. Why, I will say, don't worry. So how many numbers of angles we are going to create? We are going to create 4 numbers of angles. 4 numbers of angles are here. So actually in this 4 number of angles, this number of angles again divided into linear pair and opposite angles. It is divided into linear pair. Among these 4 angles, 2 are linear pair, because linear pair is a pair. There is a pair, so 2 angles are there. So in linear pair, how many angles are there? 2 angles are there in linear pairs. So 2 angles for linear pair and 2 angles for linear pair, and 2 are, how many remaining? The another 2 are remaining. So 2 for opposite, 2 opposite angles. Clear? So it is very clear to you now. When two lines PQ and RS are intersecting each other at the point O, how many number of angles created? The number of angles created are 1, 2, 3, 4. So 4 angles are created. Number of angles are 4. These 4 angles again divided into 2 parts. That is 2 linear, means a linear pair. That is 2 angles, and 2 opposite angles are there. So for your information, I am saying to you, now you see, I am just covering this. I am covering this person. See, I am covering from O to Q. When I am covering from O to Q, what are you observing? You see, when I am covering O to Q, then what are you observing? This is a line. This is a ray standing on the line. So now how many angles are there? 1 and 2. 1 and 2 are called adjacent angle or linear pair angle. When you will add these two, this will give you 180 degree. Now I am covering this side. See, it is very clear to you now. See, when this PQ is a line and OS is standing on the line, then how many angles are created here? 1 and 4. 1 and 4 are also called as the linear pair. So it is clear that 1 and 2, when you are covering this, 1 and 2 are linear pair. When you are covering this, 1 and 4 are the linear pair. So definitely linear pair angles are there. And opposite, see, 1 opposite is 3 and 2 opposite is 4. 1 opposite is 3 and 2 opposite is 4. These two, 1 and 3 are called as opposite angles. 2 and 4 are called as the opposite angles also. So 2 opposite angles and the linear pair angles are also there. So somebody will just cover this one. See, now you see, now it is your PQ. Now OR is standing on PQ. So 2, 3 are called as linear pair. Similarly, if I will cover this one, see, now it is your RS line and OQ is standing on that. So 3, 4 are called as the adjacent angle or linear pair angle. When you will add these two, it will give you 180 degree. So now it is very clear to you now what is called as an intersecting line. Intersecting line means two lines are going to meet each other at a point and four angles will be created. Number of angles will be 4. Among them, 2 means one pair. 2 will be linear and 2 will be opposite. So for this reason, what I did, I am going to explain you what is the relation between these four angles to each other. That to show that I just to take it with an activity. Go for an activity. Activity when you will do, it will be easy for you to understand. See now what is my activity on this. My activity is I took three figures, figure 1, figure 2 and figure 3. Here in these three figures, two lines are intersecting each other. See in figure 1, a line is intersecting straight to each other and now this is the line. This is the line intersecting, let it be line number 1 or AB, whatever you say, CD. Now AB and CD are intersecting each other. Here also take it as CD and AB. So AB is intersecting with CD at O and now it is let it be AB and this is CD intersecting at O. So in three figures, three different types of intersection I took. And how many angles created? Very simply it is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So here it is, you should give it in clockwise direction. Don't write 1 after 2 after 4. This is 3 and 4. Some students are writing like that. When you are giving the things, it should be in a particular direction, maybe in anti-clockwise or maybe in clockwise. You can write 1, 2, 3, 4 or you can write 1, 2, 3, 4 like that also. So there will be no problem for you in the further steps. So now basically I took three figures now. In these two figures you see I took some intersection lines. They are intersecting each other at O and angles created at 4. That is 1, 2, 3, 4. What I did a table for them to arrange them. This is figure number 1. Let it be figure number 1. Let it be for figure number 2. Let it be figure number 3. Understood now? So in this all cases, what I will do, I will measure my angles by protractor. I will put and I will measure my angles. What is my angle number 1? What is my angle number 2? What is my angle number 3 and angle number 4? So I have to measure them by protractor. You already know how to measure the angles by protractor also. If any doubts will come, we can clarify by asking me personally. Now you see angle number 1 here in this figure. It is very easy to understand. See in AB, OA is standing 90 degree with 90 degree, means perpendicular. So here I am writing the angles as 90, 90, 90, 90. So now you see four angles are equal to each other and these four angles are called as angles at a point. From a point these four angles came. When you will add 1 plus 2 plus 3 plus 4, it will give you compulsory two right angles. That is 360 degree. If it is not giving you, somewhere your measurement is wrong. So you have to measure them correctly and write it again. It will add you, when you will add all the angles, it will give you 360 degree. Now you see, suppose here in this case I measured this angle 1 is 70, angle 10 is 110, and then it is again coming 70, again coming 110. You will ask me, sir, how you know? Look, first you measure these two. First you measure all the angles, then I will say you what is the relation between them. What is angle 1? Look, for second figure I am writing. For second figure I am writing, see, angle 1 is 70 degree, then angle 2 is 110 degree, then angle 3 is 70 degree, then angle 4 is 110 degree. Clear? Now I wrote. What is the four angles give to me? 70 plus 110, 180, 180 plus 70, what is that? 180 plus 70, 250 plus 110, it is giving you 360 degree. I am writing here. All are giving you 360 degree. That means my measurements are correct now. Then I have to see what are the linear pairs. See, linear pairs I can say 1 plus 2. It is giving me 180 degree. Then 3 plus 4, they are also linear pairs. So see, up and down are coming as the linear pair. When you will say like this, now these two are also linear pair. When you will say like this also, these two are the linear pair. That means the adjacents. How much they are giving? When you are adding 1 plus 2, it is giving 180, and 3 and 4, it is giving you 180 also. So mention one only, angle 1 plus angle 2, angle 1 and angle 2 are linear pairs, that is 180 degree. What are the opposite angles now you see? Opposite angles means angle 1 opposite is angle 3. And what you observe from these two angles, one opposite is 3 and both are same. See, 2 angle opposite 4 angle and 2 is also equal to 4. So 110 degree. So opposite angles are what? Opposite angles are equal. Opposite angles are equal. They must be equal. Otherwise your measurements are wrong. These two angles are equal. These two angles are equal. So this opposite this. Angle 1 opposite 3. Angle 2 opposite 4. Then look at it. It is coming same. Then it is right. Then what is the remark? The remark is the last is there. The opposite angles are equal and the linear pairs are going to give you 180 degree. You measure another two figures also do like this, and another two tables. You fill yourself here the remarks. Don't forget to write the remarks. In remarks you can write what are the pairs of linear angles and what are the opposite angles. What is the relation between them, you have to write in the remarks, by which you can understand this theory behind the angles in the intersecting lines. Understood now? Thank you. The next part is a theorem. Next part is a theorem. It is a very important theorem. I put here star marks for that reason. It is a basic theorem for the intersecting line. The theorem on intersecting line. What the theorem is saying, that when you are when a question will come in exam, the prove a theorem, then these are the formats you have to maintain. Please listen very carefully. First of all, the question is the statement for you. You have to write the statement according to your question. The question will be given this one. Okay? You have to prove that. So this is your what? This is your statement. What is the statement? When the two lines are intersecting each other, then the vertically opposite angles thus formed are equal. What is saying? Again I am explaining. When the two lines are intersecting each other, two lines, what are the two lines? Then you go for the figure. Statement after the figure. According to the statement, you have to do the figure. And it should be in one line. It should be in one line. The statement, the figure, then the right to prove. This is called right to prove. What you want to prove, that is called right to prove. Then the proof is there. How to do the proof. All will be in one line. This line, these things must be maintained. And also go to the figure by reading the statement. Let's go for it. When the two lines are intersecting, let my two lines be on my figure. It is AB and CD. Both are intersecting each other at the point O. Each other. Then the vertically opposite angles. Vertically opposite means this opposite this. So BOD is vertically opposite to AOC. Understood now? BOD is vertically opposite to AOC, and always the opposite angles are vertically opposite to each other. So now in this side you see AOD, this angle is vertically opposite to BOC. This we have to prove. We have to prove BOD vertically opposite to AOC are equal. We have to prove that. And also we have to prove AOD is equal to BOC. That one I wrote here in the next step, you see, is RTP. RTP means right to prove. What you want to prove? Now BOD is equal to AOC. BOD equal to AOC and AOD is equal to BOC. So these two we have to prove now. So our proof is over. Next we have to go for proof. What is our proof? See now how I did the proof. Very easy. See, you have to say ray OA stands on CD. O to A. This ray is standing on CD. So which part I not took? This part I not took. See, this part I not took. Okay now? Now it is very easy to understand for all of you. See now, OA is standing on CD. So what are these two pair of angles? This is a pair of angles adjacent to each other, and these two angles are called as linear pair angles. When you will add these two angles, what it will give you? 180 degree. That I wrote here. See, ray OA stands on CD. Ray OA stands on CD. What is the angle? AOC angle plus AOD angle is equal to 180 degree. That one I wrote here. AOC angle, AOC angle, this angle, and AOD angle, this angle. These two angles are called linear pair angles. So they are giving you 180 degree. So this is LP. LP means linear pair. You have to write the reason in the bracket also. Let it be my equation number 1. Next, like that what I took, see, AOD plus BOD is 180. See now, I just, this OD ray, O to D, it is standing on AB. Then what is this? AOD plus BOD, these two angles are linear pair. These two angles are linear pair now. These two angles if you add, it will give you 180. That is AOD plus BOD. AOD plus BOD equal to 180 linear pair. Why? Because OD or DO stands on AB. Stands on AB. OD stands on AB. This one standing on this one. So these two are the linear pair. When you add, it will give you 180. Let it be my equation number 2. Now what I did? From 1 and 2. I saw from 1 and 2. Look, this plus this is 180. And this plus this is equal to 180. So this one is equal to this one. Because the result is same for both. So AOC plus AOD from 1 and 2. AOC plus AOD must be equal to AOD plus BOD. AOD plus BOD. Now AOD is common in both sides. I cancel. Now you see what is coming. AOC is equal to BOD. So see AOC. AOC. This is equal to BOD. What is BOD? BOD. This one. So these two are vertically opposite each other. So now it became equal. Similarly, we can prove AOD must be equal to BOC also. Similarly, we can prove AOD is equal to BOC. And hence proved, you write hence proved. After the proof, you write that. In anything, marks are there. So, after getting one equal, then you can write similarly. We can prove this angle also equal to this angle. That means AOD angle is equal to BOC angle. I hope you understood. And also try to, when you will do the things in your home, you have to be very, very careful about what I comment, how to write the theorem. The statement is a question, the figure, the RTP, the proof must be in one line. The figure clearly done. It should be clearly done. And also every namings and measurements must be written nicely. Then you can go for the RTP and proof. After the proof, you must write the hence proof. I hope you understood it. So, the next phase of the thing, here the intersecting lines are over. Up to exercise, up to we are completing, up to we completed 1 to 3 exercises. And also the next part I will show you in the next video.